In this video, we are going to derive or prove the rules for special right triangles. And we're going to start with a 45, 45, 90 triangle. So I'm just going to be showing you guys where the rule comes from in case you don't want to memorize it. So what I'm going to start by doing is labeling my legs as X. So because this is a 45, 45, 90 triangle, we know that it is an isosceles right triangle. So both of the legs, the sides that create the 90-degree angle, are congruent. So we're going to say those are both X. And now what we're trying to figure out is what is the length of the hypotenuse in terms of X. So all we're going to do for this is just use the Pythagorean theorem. So I'm actually going to label our triangle with some letters. So we're going to say A, B, C. So what we're going to say is X squared, so that leg squared plus our other leg squared has to equal our hypotenuse squared. And this is just the Pythagorean theorem. So remember, A squared plus B squared equals C squared in any right triangle. And now we're just going to solve this for AC. So X squared plus X squared gives us 2X squared on the left. And on the right, we're just going to leave it as AC squared. And now we want to get rid of the squared on the right side of our equation. So AC is by itself. So what we're going to do is take the square root of both sides. So we are going to square root the right side of our equation. We're going to square root the left side of our equation. And on the left, we're going to have the square root of 2x squared, which we'll simplify in a second. And on the right, the square root and the squared cancel each other out. So we're left with AC, which is what we want. And then we can further simplify the left a little bit. So the square root of 2 can't be simplified, so it's just the square root of 2 times the square root of x squared is just x. And I'm just going to rewrite this so it looks more like the rule you've probably learned in school. So we get that AC is equal to x times the square root of 2. So this is x times the square root of 2. And this is the ratio for any 45, 45, 90 triangle. The hypotenuse is always equal to the leg multiplied by root 2. So that's how you guys derive that rule or prove it in case you need to do that. So now what we're going to do is derive or prove the rule for 30, 60, 90 triangles, which is a bit more challenging. So now we're looking at a 30, 60, 90 triangle. So we have an angle measuring 30 degrees, 60 degrees, and a right angle measuring 90 degrees. And we want to prove the rule for this. So what we're going to do is let our hypotenuse equal x. And then what we're going to do is create a equilateral triangle. So I'm going to draw a line like this. And this is going to be 60 degrees. And this entire thing is going to be 60 degrees. And now this is going to help us figure out the side lengths of our legs of our 30, 60, 90 triangle. So because this is equilateral, we know that this entire side down here is also x. We know the side on the right is x. We won't need that, but I'll just put it in. Which means that the side across from 30 degrees in our original triangle, so this side right here is going to be half of x. So it's going to be x over 2. Because this altitude right here, this blue line right here, is going to cut our equilateral triangle into 2 congruent triangles. So we know this pink line is x over 2. And now we can use the Pythagorean theorem to find this blue line. So again, let me just label this triangle. We'll say A, B, and then we're going to do C right here. So we're only looking at this left triangle right here. So now we're going to set up the Pythagorean theorem. So we're going to say that BC, which is x over 2, so that little leg squared, plus the blue side that we're looking for, so that's AC, so we say AC squared, is equal to our hypotenuse squared. And we know our hypotenuse is x, so it's equal to x squared. Now we're just going to kind of simplify this and solve for AC. So we're going to square x over 2. So we're going to square the top and the bottom. We're going to get x squared over 4. We still have plus AC squared, which we're just going to leave as is. And this is equal to x squared. And now to get AC squared by itself, we need to subtract x squared over 4 from both sides of our equation. So on the left, we're left with AC squared. On the right, we have x squared. I'm going to write it as x squared over 1 minus x squared over 4. And then to combine these, we're going to need to make a common denominator. We're going to keep the left side as it is. Instead of x squared over 1, we're going to multiply the top and bottom by 4 to get 4x squared over 4 minus x squared over 4. And now we can combine the two fractions on the right side to get 3x squared over 4. And let's just bring this up here. So let me just rewrite this up here. So you have AC squared equals 3x squared over 4. And now to get AC by itself, we need to take the square root of both sides of our equation. On the left, we are left with AC, which is what we want. And on the right, we have the square root of 3x squared over 4. And now we're going to simplify this. So when you're taking the square root of fractions, you're taking the square root of the top and the bottom separately. Let's do the bottom first. The square root of 4 is 2, so we get 2 on the bottom. And on the top, we have the square root of 3x squared, which we can simplify a little bit more. So we can't simplify the square root of 3, so we're going to leave it as is. And x, the square root of x squared is just x. And then this is over 2. And let's just rewrite this with the x in front. So we get x times the square root of 3 over 2 as this side right here. So we get x times the square root of 3 over 2. And this is going to be the ratio for all of your 30, 60, 90 triangles. And you may be thinking that this looks a little bit different than what you've seen in school. So I'm going to draw it over here on the right side of our screen. So right now we have that our hypotenuse is x, but typically you've probably seen the hypotenuse is 2x. And from our diagram on the left, we can tell that our short leg is always half of our hypotenuse. So if we go back to our diagram on the right, we know the short leg in this case would be x, because that's half of the hypotenuse. And then if we go back to the diagram on the left, you can tell that to get from the short leg to the long leg, you just multiply by the square root of 3. So if we do that on our diagram on the right, we're going to get x times the square root of 3. So that's probably how you guys have learned it in school, is with the short leg as x. But either way you do it, this is how you can derive the equation or prove the equation for 30, 60, 90 triangles. So hopefully this video helped you guys understand where these rules come from. If you want to actually learn how to apply these rules to solving some problems, you should check out our other video that are teaching you guys how to use 45, 45, 90 triangles to solve problems and 30, 60, 90 triangles to solve problems.